Welcome to Happy Learning. So today we will be starting with a very interesting topic that is called as fins, or it is also called as extended surface. So let's begin this session by understanding the physics and the need of the fins. So consider a small flat plate, which is at a temperature of 60 degree. Let the flat plate is exposed to a surrounding which is at a temperature of say 25 degrees. So now what will happen? Whatever the heat is there from the wall, it will flow into the surrounding with the help of convection. And the convection, it is governed by the equation Q is equal to HA delta T. That is nothing but the surface temperature minus the ambient temperature, that is nothing but T infinity. So what is happening here? Whatever the heat from the plate is there, that heat which is at a high temperature, it is now moving into the environment which is at a lower temperature. So the heat flows from 60 degree to the 25 degrees. So now this heat flow, it is governed by convection. So the formula is HA delta T. Now why we are seeing this formula? We have seen the basics of convection, but why we are focusing again on the same formula? The answer to this is that many engineering applications today require improved rate of heat transfer. So now if we want to increase the heat transfer, say if you want to increase the Q by taking into consideration the same example, what are the options available with you? So from the formula, the options which are available with you is that you can increase either H, you can increase the surface area, or you can increase the temperature difference, that is nothing but Ts minus T infinity. So let's see which options which are in your hand so that it will help you to increase the Q. Why? Because many engineering applications today want that the heat should be transferred from the system into the surrounding at a faster rate. More and more heat should be dissipated quickly into the surrounding. So that's the focus today. So if this problem is given to you, so the answer to this problem is given by these three parameters. So now the first parameter is Ts minus T infinity. So this is usually fixed by design consideration. So you can't much play with it, the Ts minus T infinity. Also you can't change the ambient temperature. It is difficult. So this is a difficult option, or preferably not preferred, or much very less it is in your hand. Now the second option is the available with this to increase H. If H increases, automatically Q will increase. So H is what? H is nothing but the convective heat transfer coefficient. So now is it possible to increase the H? Yes, we can increase the H. For example, if I install a fan over here on this plate, so what will happen? Initially, before the fan, the plate to cool from 60 to 25 degrees, for the plate to attain a temperature of 25 degrees, it takes around, say for assumption, 1 hour. But now after installing a fan, what is happening? This same plate, it is cooled down to 25 degrees in half an hour. So I have increased the H value over here by installing a fan. So this is called as forced convection. So is it possible for me every time to increase the H by installing such fan? The answer to this is it is not always preferred, because for improving the H you will require a fan, or a blower, etc., which will again consume power. So this option is also not preferred because it will also consume more energy, right? And it will add up to the cost. So the only option now which is available with me is nothing but to increase the surface area, right? So if I increase the surface area, automatically my Q will increase, right? So this is how the heat transfer rate can be increased. So we are very much clear now that if you want to increase the heat transfer rate, I should increase the surface area. So how can I increase the surface area? Again, see at the bottom. See, this is the same base plate. This is the same base plate which is maintained at 60 degrees. Now what I have done, I have increased this area. This portion, this extra portion I have added to this. Now what happens? Due to this, as the surface area increases, automatically the Q increases. So without installing a fan also I can increase the heat transfer rate, and the option available to this, it is nothing but this extended surfaces. So this is called as fins. This extra thing that is coming out from the base, it is called as fins. And what is this? Why I am doing this? Why I am increasing the area? Because I want to increase the heat transfer rate. So fins are nothing but what? Here it is written, thin strips of highly conductive material. Okay, so the material used over here, it is of highly conductive material. So I hope the basic of the fin is very much clear. What is happening over here? By installing this fin on this base plate, what is happening? The heat transfer rate, it is increasing. So now let's see how the heat transfer rate, it is increasing. So before that, we will see where are the fins applied and why. So the second point is, where are the fins applied? So usually the fins are applied, for example, before seeing, let's see, this is a plain wall. Okay, on this side it is a hot fluid, and on this side it is air or gas. Okay, so now this is at a higher temperature, say 70 degree. So what will happen? The heat will flow from the hot liquid into the wall, and from the wall into the surrounding, right? So usually the fins are applied on the gas side. Why? Because the H value of the gas, it is very less as compared to the liquid side. Hence value of H on the gas side, it is very less as compared to liquid side. So to compensate this low value of H, the area, it is increased, and in this way you can see the fins are added on the gas side. So this extended surface will now help to increase the heat transfer rate. So this one point you should keep it into mind, that fins are usually employed on the gas side. Why? Because on the liquid side fins are not employed. Why? Because the H value is usually high, and for the gas side the H value is low. Hence the fins are applied on the gas side, right? So we have seen what do you mean by fins. Fins are nothing but extended portion is added to the surface so as to increase the heat transfer rate. This extended area helps to increase the heat transfer rate, right? Now next thing, how the heat flows through the surface, that we will see now. Okay, this we will see what happens to the fin. Okay, now the basic function of fin is what? To enhance the heat transfer rate from the surface by exposing large area to convection. This is what is the fin doing. Now you can see that this area, it is exposed to this whole surface. It is exposed to what? Convection. So the heat is flowing out by convection. So in this way, as the area increases, the area available for convection also increases. Hence the heat transfer rate increases. So now we will see how the heat is flowing through the fin. So let's see. Heat transfer process through the fin, right? Here it is written, the process of heat flow from the fin is associated by two processes. How the heat is flowing through the fins? The heat is flowing by the two processes. First one is the conduction and second one is the convection, right? So now let's focus how the heat is flowing. So now again we will go back to the same image. Sorry for the smaller image. So now this plate is at a higher temperature, say for example 60 degrees. So now what will happen? The heat will initially flow from the base plate into the surface of the fin, right? See, the heat is flowing into the surface of the fin by conduction. So first, how the heat is flowing? First the heat is flowing by conduction, and later on it is flowing into the environment. See, from here it is flowing, and from the bottom also the area is exposed to air, and later on it is flowing into the environment by conduction. Later on it is flowing into the environment by convection. So in this way the heat is flowing. Okay, so I hope how the heat flows through the fin is clear. The heat flows through the fin by two modes. First is conduction. The heat is conducted from the base plate into the fin, and later on from the surface it is convected into the environment. So you should keep these two things into consideration, right? Now the rate of heat flow for conduction, it is governed by which? The K value of the material and the cross sectional area. So this is one important point, that the conduction phenomena in fins, it is governed by the thermal conductivity of the material and the cross sectional area of the material of the fin. And for convection it is governed by which? Again it is governed by H and the surface area. So as I have told you in the previous videos also, that whenever conduction is there, we will take into consideration the cross sectional area, and for convection we usually take into consideration the surface area. So I hope how the heat flows through the fin is very much clear. Now we will see what is happening in the fin when the heat flows. So now if this is the fin, okay, so when the heat flows through the fin, what is happening? The heat, it flows into the fin by conduction first and later into the environment by convection. So now what is happening over the temperature? Let's see. So this is the temperature of the fin base plate, right? If this is the temperature of the base plate, as we move on in the direction of the fin, what is happening? The temperature across the plate, it is decreasing. So this thing you should keep into mind, that whenever the fin, as we are moving away from the wall, what is happening? The temperature is dropping. So you can see that the drop in temperature, I have shown this here with this graph. See, at the base plate, the temperature at the fin, it is nothing but the temperature of the base. But as we go on moving in the direction of the fin, across the length of the fin, what will happen? The temperature, it will decrease. So if we take too long fin, what will happen? The temperature, it will attain at the end the surrounding temperature. So usually the length of the fin should be such selected that it will give optimum heat transfer rate. Okay, why? Because for example, if we use too longer fin, what will happen? The fin will attain the temperature of the surrounding and it will be of no use. So proper length of the fin should be selected. So this is one important point that you should keep into consideration while designing a fin, that a proper length of the fin should be selected, right? Next thing, where do you find the fin? The applications. First application, okay, let's see the application where the fins are used. The first application is nothing but the car radiator. So what is a car radiator? Car radiator is basically a tubular element. On the tubes the fins are attached. Now what is happening? The hot coolant, it is flowing into the tubes. Now why the coolant is hot? Because it is taking away the heat from the engine. That heat is carried away by the coolant. The temperature increases and that hot coolant flows inside the tube. And above the tube, what is there? The fins are attached. So what happens? The air flows between the tubes, and due to this, the temperature of the coolant falls. So basic use is nothing but the car radiator. Second example is nothing but the electrical transformer. Many of you might have seen an electrical transformer installed at an electrical pole. So what is happening? Whatever the heat which is generated into the transformer, that heat, it is removed out with the help of fins. You can see a long fins available over there. So the heat that is generated there, that is taken out with the help of fin. So the cooling process is taking fast. Third, and the very most important application that we have seen in your day-to-day life is nothing but the IC engines. So basically on the IC engine, you have seen this type of structures like this, right? So what are this? They are nothing but they are fins. Why they are applied on the cylinders and the cylinder head? So that the cylinder gets cooled quickly. So they are nothing but fins. Okay, so I hope you have got the clear understanding where the fins are used. They are used in car radiators, transformers, IC engine. Another applications is nothing but the heat sinks that are usually used in electronic equipments for the proper air cooling, right? Now let's see the types of the fins. So usually the fins can be classified into three types, right? The first is nothing but longitudinal fins. So here you can see that the fins, they are available in variety of shapes. So first is nothing but a rectangular profile. So these are the rectangular profile fins. This is also a rectangular profile. A rectangular portion, it is attached to the base plate. Same for a circular section, a rectangular profile fin, it is attached. Now the fin can be of a trapezoidal profile also. You can see it is a trapezoidal profile. Also it can be in a concave shape also. Here you can see a concave shape. Second is nothing but the radial fins. So now what are radial fins? Radial fins are nothing but they are attached circumferentially to a cylindrical surface. So they are attached circumferentially to a cylindrical surface. So this is a rectangular profile and this is a triangular profile. Now the cross-sectional area of the fin, it can be fixed or it can be varying also. Okay. So now this initially, this you can see this is the uniform cross-sectional fin. But here if you go in the particular this direction, the cross-sectional area, it increases. The cross-sectional area is not uniform. So fins are also classified on the basis of uniform cross-section or non-uniform cross-section. So we have seen first the longitudinal type, second nothing but the radial type. Now the last type is nothing but pin fins. So here you can see that what are pin fins? Pin fins, or it is also called as spines. So what are pin fins or spines? They are extended surface of circular cross section which may be uniform or non-uniform. So this first one is a uniform one, and this you can see this tapered and the concave one, they are not uniform one. So thus pin or spines, they represent a cylindrical or conical rod protruding from a wall. So you can see this is a plain small cylindrical rod that is protruding out from a wall. So this is also another type of fin. So we have seen the three types. First one is the longitudinal, radial, and the third one is nothing but pin fins. So just to sum up with the lecture, we have seen what do you mean by fins, why we utilize the fins. We utilize the fin because we want to increase the heat transfer rate, because this is the need of the hour. Secondly, we have seen how the heat flows through the fin. The heat flows from the base into the fin material by conduction and from the material into the environment by convection. Later on we have seen the applications and the types of fin. So I hope this quick session has given you an idea regarding to what are the fins and the types of fin. So in the next session we will see the governing equation for fins. So till then, keep learning, happy learning. Thank you.